In this video, we'll talk about square roots, kind of what they are, some perfect squares, and some applications for square roots. So let's dive right in. Let's talk about what a square root is. So we have an equation, x squared equals 49, and the whole idea is I want to know what x is. But how do I undo a squaring? And the answer to that is a little difficult. So what mathematicians have come up with is a square root. So x equals the square root of 49. It's kind of like a division sign with a little tail. Now, we might be able to think about this one because we know 49 is a perfect square. We know that 7 times 7 equals 49. Okay, so then it would stand to reason that 7 squared is equal to 49. So x could be 7. But the question here is that the only number that I take times itself to make a positive 49? And the answer to that question is no. What if I had negative 7 times negative 7? So then my potential pool of answers would be x could be 7 or x could be negative 7. Or, being the important word, I don't know which one it is necessarily. It could be one of the two. So another way of writing this, instead of writing two long expressions with equations here, I guess, we can say x equals plus or minus 7. So both of these are totally fine as solutions. But the whole idea of a square root is it undoes a squaring. Now let's go through, let's talk about some perfect squares. So the first perfect square is 1. And its square root is 1. It's a whole number. Okay? The next one up is 4. The square root of 4 is 2. Next one is 9, so square root of 9 equals 3. And then we have the square root of 16 equals 4. The square root of 25 equals 5. The square root of 36 equals 6. The square root of 49, we've talked about this one, that's 7. And the square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. I think you get the idea here. And then something worth noting, every single one of these we can do a plus or a minus. We don't necessarily know whether it's the positive case or the negative case, and that's going to be kind of dictated by what our context is. So let's say we have a square. And I don't know anything else about the square except its area is 144 square feet. And I want to know, what's the side length? Okay, well, I know that in the case of a square, its side lengths are the same, and I also know that the length times the height, so in this case x times x, equals the area. Now, realistically, I could combine this down to be x squared equals, and I'm going to go ahead and use the 144 for this particular square. We know this to be true. So, in this case, we're going to take a square root. So x equals the square root of 144. And, well, normally we throw in the plus or minus. So let's do that. So x equals plus or minus 12. Now, can you have a negative 12 side length? The answer is no. It doesn't make sense given the context. So I can actually eliminate that possibility and just say, okay, x is 12 feet. It would make sense to say x is negative 12 feet. Now, the reason the negative pops in is because theoretically if we fix this to a coordinate grid, well, yeah, we could have essentially a square with negative coordinates, and it would still be of the same size. So that's where the negative comes from. So there's one application of using square roots, and then some application of sometimes we can toss out the negative possibility. But if we don't know any context, we have to account for it always.